Good day. Welcome to Mr. Rocha's Flip Class Math 10 Low Cost, Low Tech videos. This is a continuation of the Right Triangle Trigonometry series. This is part 4, and specifically it's to do with applications and problem solving using right triangle trig ratios. I have a variety of types of questions that you could encounter in this section. I'm not going to solve these. I'm just going to give you kind of a strategy or a start to how I could go about solving these questions. First type of question is a clinometer question. This clinometer allows us to measure an angle of elevation to the top of a tree or a cliff or a building or whatever. And we have to determine the height of that tree or cliff or building or whatever. We could also determine the line of sight, the length of that, or a variety of other things in this question. First of all, if they do say that a homemade clinometer is used, remember that the angle that is being read off the side of the clinometer, if it says 60 degrees, for example, that's not this bottom angle. It's actually this angle up here. We have to subtract that angle from 90 to get this angle. So, this right triangle would look like this. Line of sight, looking through the straw of the homemade clinometer. This would be, assumably parallel to the ground. So if this says 60 degrees on this homemade clinometer, we're actually going to have an angle of elevation of 30 degrees. That's the 60 up here. If we know this baseline measurement is, say, 40 meters, we can now calculate the height of the tree, because this would be a right angle. This would be the side opposite the angle of 30 degrees. This would be the adjacent. So the tangent of 30 degrees equals opposite, we could call it x, over the adjacent, which we could call it 40 meters. So tangent of 30 equals x over 40, opposite over adjacent. At this point, we would find what the tangent ratio of 30 degrees is, replace that with that decimal number, and do my cross multiplying to solve for x. Now don't forget, that would only be the height of the tree from this point, even with the person's eye level, to the top. We still have to add this part of the tree, which would be the same as the height of the person to the eyeball. So if this person is 2 meters to the eyeball, we would have to add 2 meters to the height of the tree to get the overall height of the tree. Okay. The next type of question you could encounter have to do with bearings, which is a directional travel. We always measure bearings in a clockwise direction from north. So for example, if it says a ship leaves port and travels in a direction of 90 degrees, here's port, we'll call it P. 90 degrees would be 90 degrees from north, boom, right here. It would be traveling east. 180 would be south, 270 would be west, and 0 or 360 degrees would be north. You'd see those same markings on any handheld compass so that you could actually follow it a certain bearing. Now suppose the ship was sailing due 200 degrees, a bearing of 200 degrees. Well, there's 90, there's 180, 200 would be another 20 degrees past that. So it would be going in that southwesterly direction. Okay? And then it might say there would be a change of direction. It might go back up here. Somewhere along the line, it will be a right angle form so that we can indeed use trigonometry to finish solving our problem. Another scenario would involve circles. Now with circles we have things called chords, which run across the circle. If it runs through the center, that chord would be called a diameter. But if it doesn't run through the center, we just call it a chord. And this line here is called a perpendicular bisector because it divides the chord in half. It goes through the center of the circle, which I marked C, and does so at, where the bisector hits the chord at right angles. So therefore we could have a radius here, and we could figure out some things including the length of the radius, or half that chord, or this distance here. We can figure all sorts of stuff, including angles and so forth, depending on the information that's given to us. In this situation, we have two tangents shown, not to be confused with trigonometry tangent. Tangents can also be described as lines that touch a circle in exactly one place. So that's a tangent, so is that. If you have two tangents going to the same external point, those two tangents will be equal length. Okay? The tangents touch the circle at a point of tangency. That's a point of tangency. And furthermore, it will meet the radius of the circle at right angles, or at 90 degrees. So those are both right angles. So if we had a line here from the center straight to the external point, we now have a right triangle formed and another one. So we could start asking questions about these angles, these sides, and through a process of using trigonometry and or Pythagoras, we can find all sorts of stuff about those circles. The last type of application question I want to show you is to do with more than one triangle problems. So in this case here, we have a plane, that's a beautiful plane, flying towards two fires. And the question might have something to do with how far are the fires apart. They could give us all sorts of information. For example, they might say the plane is so many meters off the ground, let's say 200 meters above the ground, and the pilot's sight down to the first fire might be an angle of depression of so many degrees. So remember, the angle of depression is from horizontal looking downwards. So if I put a line of sight here for the pilot, this would be the angle of depression. So if the angle of depression to this fire is 30 degrees, okay, then this part here is 60 degrees. So now we have this side, we have an angle, we can figure out this distance right here to that fire, directly below them to the fire. Now, if the angle of depression to the second fire, say, is 15 degrees, then this angle, looking at this blue triangle now, would be 75 degrees for a total of 90. So that's 75 degrees. This is also 200. Now we can figure out this distance. And through a process of simple subtraction, this distance minus this distance would be the distance between the two fires. Here's another case where we have two triangles. One's on one plane and the other one is perpendicular on a second plane. So you can see that this triangle, the black one, is a right triangle. So is the red one, but we're looking at it on an angle. So this is the right angle here at the bottom of the tree. We might have a task here, find the height of the tree. So using the bottom triangle, first of all, we have an angle, a reference angle. We have this side across from the right angle, so that's the hypotenuse. And we could find this side here, which is the side opposite here. So opposite and hypotenuse is sine. So if we take the sine of 40 degrees, turn that to a ratio, a decimal ratio, equals opposite over hypotenuse. That will allow us to find this side. And once we have this side, we have an angle of inclination here. We have an adjacent side, and we're looking for the opposite side. So we could find, call it y, the height of the tree, using tangent. Okay? Here's another situation. This is like a clear box. It's a rectangular prism. All the corners are 90 degrees, including these ones here. Perhaps you might ask a question like, what's the longest length stick that we could put inside that box? The longest length stick, you would have to lie diagonally from the top corner down to the bottom corner. So it might look like this. There we go. What's the longest length stick? Well, I have to make a couple of triangles in order to solve that problem. So, let's see. I could find this side here, this diagonal of the base, of the bottom, because that rectangle is 50 by 25. Okay? This side here is also 25. So, a squared plus b squared, here's my right angle, equals c squared. I could find that side. And once I have that side, this is also a right angle. If you visualize that, you know, turned up a bit, get a little bit of artistic impression. That's a right triangle. So again, I have this side now, plus this side, Let's see, and that side is 30, so that side is also 30 centimeters. So a squared plus b squared is c squared. Okay, so I didn't need any trig to solve that particular problem. I could use Pythagoras twice. However, what if it said, if that stick was up there, and let's say an ant was looking to walk up this line, what would his angle of inclination be? So we would have to determine that angle. That would be, this would be flat along the bottom of the box, and this would be the angle of inclination going up, or angle of elevation, same thing. Okay? We could also find the angle of depression, which is from the top down, or maybe this angle here, which is 90 minus the angle of depression. So there's all sorts of things that we could ask using trig as well. So hopefully that helps you find some strategies to solving questions with more than one triangle or any other application type questions. That concludes the trigonometry unit, and hopefully you found these units helpful. Hopefully you were able to generate some notes and come to class with some good questions and ready for some discussion. Thanks for now. We'll see you soon.